Hello, my name is Yossaphan Kaenwong. My student ID is 653640844. In this interview, I will presentation 3 of the transport layer. User Datagram Protocol or UDP. The UDP is the conditionless unreliable transport protocol. It does not add anything to service of IP except for providing process-to-process instead of host-to-host communication. UDP is a really simple protocol using a minimum of overhead. So UDP packets called user datagrams have a fixed size header of 8 bytes made of 4 fields, each of 2 bytes. And this picture is the user datagram packet format. For in the header, it has a source port number, destination port number, total range, and checksum. In UDP service area, we discuss the general service provided by a transport layer protocol. In this section, we discuss what portions of those general services are provided by UDP. Process-to-process communication use socket addresses, a combination of IP addresses and port numbers. Connectionless service, an independent datagram, not number, no connection establishment and termination. Flow control is no flow control, and error control is no error control. In checksum is optional inclusion for of checksum. Congestion control, encapsulation to send a message from one process to another. Queuing in UDP, queues are associated with ports and the client side. When a process starts, it requests a port number from the operating system. Multiplexing and demultiplexing, only one UDP but possible several processes. Comparison UDP and simple protocol. UDP provides an optional checksum to detect corrupted packets at the receiver side. Pseudo header for checksum calculation. In UDP checksum calculations, it have a pseudo header, the UDP header, and the data. The pseudo header, the part of the IP packet in which the user datagram is to be encapsulated. The value of the protocol field for UDP is 17. If its value is changed, we'll detect it or drop. In UDP applications, although UDP meets almost none of the criteria we mentioned earlier for reliable transport layer protocol, UDP is preferable for some applications. The reason is that some services may have some side effects that are either unacceptable or not preferable, and application designers sometimes need to compromise to get the optimum. In UDP features, it have a connectionless service, lack of error control, lack of congestion control, and typical applications. Transmission Control Protocol or TCP is a connection-oriented, reliable protocol. TCP explicitly defines connection establishment, data transfer, and connection share rates. To provide a connection-oriented service, TCP used a combination of GBN and SR protocols to provide reliability. TCP used checksum for error detection, retransmission of lost or corrupt packets, cumulative and selective acknowledgement, and timers. TCP service. Before discussing TCP in detail, let us explain the service offered by TCP to the processes at the application layer. Process-to-process communication is using port numbers, as the delivery service is have sending and receiving buffers and segments. Full duplex communication. Data can flow on both directions at the same time. Multiplexing and demultiplexing is and a connection needs to be established for each pair of processes. Connection-oriented service establishment, data exchange, and termination. Reliable service use an acknowledgement mechanism to check the safe and sound arrival of data. And this picture is now a stream delivery. TCP creates an environment in which the two processes seem to be connected by an imaginary tube that carries their bytes across the internet. The sending process produces the stream and the receiving process consumes it. In this picture is sending and receiving buffer. TCP needs buffer for storage using a calculus array of 1 byte locations. TCP segment. The groups a number of bytes together into a package called a segment. TCP adds a header to each segment and delivers the segment to the network layer for transmission. The segments are encapsulated in a IP datagram and transmitted. TCP feature to provide the service mentioned in the previous section. TCP has several features that are briefly summarized and this section and discussed later in detail. Numbering system. Byte number. The byte of data being transferred in this connection are numbered by TCP. The numbers start with a arbitrarily generated number. Sequence number. The sequence number of the first segment is ISN, a random number. The sequence number. The sequence numbers of previous segment plus the number of bytes. When carrying only control information needs a sequence number. Acknowledgement number. The number of next byte cumulative. Segment. Before discussing TCP in more detail, let us discuss the TCP packets themselves. A packet in TCP is called a segment. So in this picture is the TCP segment format. So in sequence number, the number assigned to all the first byte of data contained in this segment. Acknowledged number, the byte number that the receiver and of the segment is expecting to receive. Header range, the number of 4 byte words. Window size, the window size of sending TCP in bytes determined by the receiver. Checksum mandatory for TCP or UDP optional. The value of protocol field is 6. Control field. In the control field is have a URG, ACK, PHH, RST, SYN, and FIN. So one or more of these bits can be set at a time. This bit enable for control, connection establishment and termination, connection abortion, and the mode of data transfer in TCP. So in this picture is the pseudo header add to the TCP datagram. A TCP connection. TCP is connection oriented. As discussed before, a connection oriented transport protocol establishes a logical path between the source and destination of the segment belonging to a message are then sent over this logical path using a single logical pathway for the entire message. Facilitate to acknowledgement process as well as retransmission of damaged or lost frames. In connection establishment, it has a three-way handshaking, SYN forwarding attack. Data transfer is a pushing data and urgent data. Connection termination is a three-way handshaking and half cross. Connection reset. The TCP and front end may deny a connection request, may abort an existing connection, or may determinate an idle connection. So in this picture is the connection is using three-way handshaking by SYN forwarding attack, susceptible to a serious security problem, denial of service attack, when one or more malicious attackers send a large number of SYN segments to a server. One recent strategy using cookies, HTTP. So in the first inactive open is the sense the SYN segment cannot carry data but it consumes one sequence number. So in the server, in the second is the SYN plus ACK segments cannot carry data, but it consumes one sequence number. So in client send back to the server, it's ACK segments if carrying no data consume no sequence number. This picture is the data transfer. The sending TCP must not wait for the window to be filled. It must create a segment and send it immediately to push operation. In this picture is the connection termination using two-way handshaking. By the first, if the fin segment consume one sequence number if it not carry data, and the second is a fins plus ACK segments consumes only one sequence number if it does not carry data, and the last, in this segment cannot carry data and consume no sequence number. And this picture is a half course. In TCP, one end can stop sending data while still receiving data. Example is sorting state transmission diagram to keep track of all the different events happening during connection establishment, connection termination, and data transfer. TCP is specified as a finite state machine or FSM, as shown in figure 3.51 scenarios and half-core scenarios. Windows in TCP. TCP used two windows for each direction of data transfer, which means 4 windows for a bidirectional communication. To make the discussion simple, we make an unrealistic unidirectional. So in this picture is the send window in TCP, and this is the receive window in TCP. Flow control. As discussed before, flow control balance the rate of producer create the data with the rate of consumer can use the data. TCP separate flow control from error control. So in this continue is have an opening and closing window by a scenario, shrinking of window shutdown, sending a RWNT of zeros, stop sending data until a new advertisement has arrived. Silly window syndrome created by its senders is Nagel algorithm, and syndrome created by the receiver is craft solution. In this picture is the data flow and flow control feedback in TCP. So in the back line is data flow and late line is flow control feedback. All discussion of flow control concentrates on the feedback sent from the receiving TCP to sending TCP. And this is an example of flow control. It's the opening and closing windows. The send and receive windows are set during the connection established phase, and how this situation will change during data transfer. Error control. TCP is a reliable transport layer protocol. This means that an application program that delivers a stream of data to TCP relies on TCP to deliver the entire stream to the application program on the other end in order without error and without any path lost or duplicated. To the continue, continue the checksums acknowledgement. In the acknowledgement, it have a cumulative acknowledgement, so it's the ACK, and the selective acknowledgement is SACK. Generating acknowledgements, retransmission of other segments. FSM for data transfer in TCP is have a sender and a receiver. Some scenario is have a normal operations, lost segments, fast retransmission, delays segments, duplicate segments, automatically correct lost ACK, correction by resending a segment, deadlock created by loss acknowledgement. And this picture is the normal operations. So in loop 1, when NA sends a data segment to NB, it must include an acknowledgement. The receive and rule 2 is the receiver needs to delay sending an ACK segment if there is only one outstanding in other segment. Rule 3, there should not be more than 2 in other acknowledged segment at any time. Lost segment. Rule 3, there should be more than 2 in other acknowledgement segment at any time. Rule 4, when a segment arrives with an out of the sequence number, the receiver immediately sends a ACK segment announcing the sequence number of the next expect segment. Rule 5, when the missing segment arrives, the receiver sends an ACK segment to announce to the next sequence number expect. And this is a fast retransmission. And this is loss acknowledgement by loss by server in ACK 701. And this is a loss acknowledgement correct by resending segments by its loss acknowledgement by a server. It's TCP congestion control. TCP uses different policies to handle the congestion in the network. We describe the policies in this section. So, in this picture is slow start, exponential increase. In the slow start algorithm, the size of the congestion window increased exponentially until it reached a threshold. When the size of the window in bytes reach this threshold, slow start stop and the next phase start. And this is the congestion avoidance additive increase. In a congestion avoidance algorithm, the size of the congestion window increases additively until congestion is detected. So, in summary, UDP is a transport protocol that creates a process-to-process communication. UDP is a reliable and unreliable and connection-less protocol that requires little overhead and offers fast delivery. The UDP packet is called a user datagram. Transmission Control Protocol or TCP is another transport layer protocol in this TCP/IP protocol set. The TCP provides process-to-process, full duplex, and connection-oriented service. The unit of data transfer between two devices using TCP software is called a segment. A TCP connection consists of 3 phases: connection establishment, data transfer, and connection termination. TCP software is normally implemented as a finished state machine or FSM. Thank you.